Hi, I'm Melorine and I'm a member of Solar House Design Team. We are a team of students from Missouri University of Science and Technology in Rolla, Missouri, dedicated to designing a sustainable net zero energy home for people with mobility related disabilities. Today, our team will be presenting the Flight Home in the Suburban Single Family Housing category. Today, our presentation will cover an introduction to the team and the team's design goals, architecture of the home, engineering behind the home, energy and cost analysis, and a conclusion. Our team consists of two faculty advisors, Dr. Stuart Bauer and Dr. Heath Pickerel, and our team consists of 10 undergraduate student members. Presenting with me today will be Alyssa, Troy, and Aditya. As for our partner introduction, this year, Solar House Design Team has partnered with Operation Triage during the design phases of this project. The Operation Triage's mission is to provide emergency financial relief, mortgage-free homes, and home remodeling to disabled veterans, first responders, and active duty service members in an effort to get their lives back on track and become productive members of their communities. Operation Triage has aligned Solar House Design Team with a veteran client that has offered the team more insight regarding the client's needs. In addition, they've also provided insight on our completely accessible floor plan. Regarding architecture of the house, the main goal of the architecture is to allow freedom and independence for all, combining function with cutting-edge technology. In this section, we'll discuss our design goals, design concept, site features, design choices, and climate considerations. Our three main design goals include accessibility, affordability, and net zero energy. Regarding accessibility, the team's goal was to ensure all spaces in the home were accessible for people with mobility-related disabilities. Regarding affordability, the team wanted to create a cost-effective home for an occupant with a limited income. Regarding net zero energy, the team wanted to design a home that generated energy from renewable resources to compensate for its energy consumption. The target market for the home is a lower limb amputee veteran between the ages of 25 and 40 years old. Ideally, this client would have a roommate or is developing a family. In addition, the design can be modified to accommodate a growing family beyond 2 bedrooms. Also, ideally, the student would be pursuing a degree at Missouri S&T or would be a university staff member. Regarding accessible housing data, in 2011, the U.S. Census Bureau reported that only 9% of households with a disability actually lived in an accessible home. Ultimately, the team wanted to design a home that combated the issue of veteran homelessness and poverty while also adding more accessible housing to the housing market. Now I'll pass you over to Alyssa to introduce our design concept and site details.
Thank you, Mel. So FLIGHT is an acronym as follows: Freedom to Live Independently, Green Housing for Tomorrow. When coming up with a design concept, the intended occupant would need to be able to fully utilize its features like anyone else with any ability would be able to do. Additionally, the team's attention to detail is seen throughout the home, even in the chosen color of navy blue for the exterior siding. The color theory for navy blue often represents strength, honor, bravery, and power. Since people with disabilities can often feel powerless and frustrated, the team wanted the occupant to feel empowered by their environment. Overall, every aspect of the architecture was designed to provide a highly functional, comfortable home for the intended occupant. So here you'll see some interior and exterior renderings on, which I will go into detail on those further. So with the site features, I'll go into the community settings, climate, affordability, brief travel times, and the landscapings. The home itself is located within Rolla, Missouri. Much of the population is centered around campus, and the site location is 2 miles from this campus and from downtown. The climate is located within climate zone 4A, meaning that it typically has cold winters and hot, muggy summers. So here's some photos of the undeveloped land and the lot lines. The land sits on 2.2 acres of land, and it is highly affordable. As you can see here, the price was lowered from $40,500 to $18,000 and now to $15,000. So the route taken by car from the home is approximately 4 minutes, and the bike route is approximately 10 minutes. Both these things are 1.7 miles from campus itself. So with the site landscaping features, we wanted to keep a lot of the trees that are already planted there as they're already established, but with the ones that will plant, the shrubs and things like that, it'll help with aesthetics. They will be native species and they will be low maintenance. So here are some of the things I'll touch briefly on within the design choices, including indoor durability and resistance, codes and standards, ADA compliance, and the building science. So here's the floor plan. We wanted to go for an open concept floor plan, being wheelchair accessible, sliding doors for easy access, can be expanded to accommodate a growing family, and there's a strong use of daylighting to maximize sunlight throughout the house, which was very important for us. So here are some of the codes and standards that would be enforced: ADA compliance, ASHRAE standards 62.2 2019, among other things. So with the home being ADA compliant, we wanted it to be single story, have polished concrete floors as they are highly durable and low maintenance, wide turning radii and appliances on lower elevations, and grab bars around every toilet and a walk-in shower in the master. Troy's going to touch briefly on the Department of Energy's Zero Home Ready program, and then I'll go into climate considerations.
Thanks for that, Alyssa. Now, real shortly, I just want to go over the Department of Energy's Zero Energy Ready Home program. Energy Star qualifications is one of the requirements for the 2021 Department of Energy Solar Decathlon. As you can see, this list of requirements is below: an envelope, duct system, water efficiency, lighting and appliances, indoor air quality, and renewable ready checklist. 5 of these 6 prerequisites are shown completed in the document on the right side of the screen, which is the Energy Star certification of the home. On this Energy Star certification, you can see values such as the R value of the walls, ceiling, floor, slab, water efficiency values, heating and cooling efficiency values. Lots of useful information is included. But the one thing that's not included is the Renewable Ready checklist, which was completed within the project summary. The Renewable Ready checklists included documentation that shows that the flight home is ready for a photovoltaic array to be installed on top of the home. Now I'm going to kick things over to Alyssa for climate consideration.
Thank you, Troy. So like I said, I'll be going to climate considerations, talking about how the home is environmentally friendly, meeting net zero energy goals, and talk a little bit about the building science layers. The magnesium oxide boards are mold, fire, and water resistant, contain no VOCs, and have an R value of 43 or higher. These boards can also be ground down and used in concrete when they are no longer usable. With denim insulation, it's composed of 85% recycled content. They improve the indoor air quality. They have superior sound absorption and an R value of 19. The stainless steel siding is 100% recyclable, withstands extreme weather conditions, and they're low maintenance. The rib steel roof panels are listed with Energy Star, prevent heat from leaking into the home, and are virtually maintenance free. So here you'll see some of the exterior building science layers. You'll see how I lined that all up. With here you see the interior wall sections. You'll see the magnesium oxide board featured here, metal studs, denim insulation, and so forth. With the building science layers of the roof and floor, you'll see the layer of polished concrete, the steel panel roof. We use spray foam insulation to prevent air and water from leaking into the home. So that concludes the architecture portion of this presentation. Thank you for hanging in there with me, and I'm going to pass you along to Aditya where he'll discuss the engineering. Thank you.
Okay, thank you, Alyssa. So my name is Aditya, and I will be telling you about the engineering systems in our building. Up first is our plumbing system. We have a hybrid heat pump water heater, which this one specifically is up to 4 times more efficient than your conventional gas or electric tank water heater, so very, very efficient. And I'd also like you to note the centralized location of our water heater. This will provide a very short path to any of the water plumbing fixtures, and the hot water pipes will also have R3 insulation around them to reduce energy loss. And we will also be using a water heater with a 50-gallon capacity, and I know that this sounds like a lot, but if you remember the target market, we want the occupants to be able to expand their family and start a new family. And a 50-gallon capacity will easily be able to accommodate a growing family 8 or 9 years down the line. Water conservation is very important for our project. Whenever applicable, our plumbing fixtures are water sense labeled. And to put this into perspective, the toilet alone can save up to 13,000 gallons of water a year. And then this last one on the first row is a weather tracking irrigation control system, which helps prevent overwatering of your lawn. It keeps track of the weather forecast, so that way, say if there's rain in the forecast tomorrow, it will water your lawn today. And then on the bottom row, your kitchen faucet, dishwasher, and washing machine, they aren't part of the water sense program. So instead we chose a faucet with a very low flow rate, and the other two have auto sensing technology to make sure you don't use more water than necessary. Heating and air conditioning, we will be using a ductless mini split system, which is much more efficient and take up less space than ducted systems. Our specific Mitsubishi unit boasts its hyperheat technology, which allows it to perform at 76% capacity, even when it's negative 13 degrees outside. And our indoor units are placed based on convenience. So you have a small unit in the master bedroom, a large unit in the main living area for the living room, kitchen, and solar room, and then a medium-sized unit to provide for the other bedroom and then the office. Ventilation is very important for a building. It takes out stale exhaust air, which can contain odors, VOCs, and moisture. Moisture especially can accumulate in building walls and damage the structural elements. So for this reason, the exhaust vents are placed in your bathrooms and kitchens. And the supply vents will be placed in the main living areas, like your living room and bedrooms, and they'll be placed in closets when applicable, so they won't really be a burden to the occupants. We will also be using a heat recovery ventilator, and this contains a heat exchanger to bring the incoming fresh air streams and exhaust streams closer to temperature. And this reduces temperature fluctuations in the house and reduces the loads on your mini split system. And they will also be fitted with MERV 13 filters, which are really high, really efficient, and will ensure clean air throughout the house. Lighting, we wanted to be able to take full use of daylighting, so we have a lot of large windows throughout the public areas. Our entrance will have vintage style light bulbs with a nice warm glow, so they're very inviting. Our kitchen will have bright LED strips, so you will be able to see what you're doing on the countertops. And then everywhere else, we will be using Philips VR30s, which segues us into smart technology. So we have a lot of applications of smart technology to make life easier for the occupants. For example, with the lighting, the lights can be controlled by a phone app, and you can control everything from like their shade to hue and color and all of that. On the plumbing system, the water heater and irrigation control systems can be monitored through your phone. For mechanical, all 3 indoor units of your HVAC system will be fitted with wireless interface controllers, so they can connect to a Kumo smart thermostat and a phone app, so you can control them from anywhere you want. And then finally, on the electrical side, we have a Tesla Powerwall 2, so that you can track your energy consumption and generation from wherever you want. And with that, I will hand it over to Troy.
Thank you, Aditya. Now I'm going to go over some of the smart technologies implemented within the Tesla Powerwall 2, which is one of the largest solar batteries on the open market currently, with a whopping 14 kilowatt hours of storage, which equates to around 13.5 kilowatt hours of usable storage. These Tesla walls are stackable as well, which is perfect for our expanding household, meaning we can add more to the system when the time comes. You can control the Powerwall entirely from its app. Set preferences within the app to optimize energy independence, power outage protection, and savings. With instant alerts and remote access, you can control the system from anywhere. Next, I'm going to start to go over the renewable energy system implemented within the home. So starting in the top left corner, we have our 25 SunPower 400-watt solar panels that export around 10 kilowatts of energy every hour into the Fronius Simo 12 kilowatt inverter, which sends rectified usable AC current to the Tesla backup gateway 2. The inverter has an additional element attached, which is the Data Manager 2.0, which when connected through a basic Cat5 cable sends system overview to the online portal, allowing the homeowner to monitor their array status in real time. The Tesla Backup Gateway 2 is connected to the utility meter not shown in this diagram, the circuit breaker panel, and the Tesla Powerwall 2. Due to our home being self-sufficient, the backup gateway should hardly interact with the utility meter and should send all of the usable power to the Tesla Powerwall 2 or to the home when the demand is there. Any extra power will be stored in the Powerwall until loads request the energy when not enough is being supplied through the solar array. This should send safe, usable power into the home 24 hours a day, 365 days a year. Now, you may have noticed that you can also interact with the Tesla Backup Gateway 2 through the Tesla app, which allows you to get real-time system overview and control notifications sent directly to your phone. This allows our user to interact with their renewable energy system anywhere they are. Next, I'm going to go over an energy production analysis. So this is a figure from the National Renewable Energy Laboratory on the estimated power production of our solar array. These numbers are reflective of a solar array within 1 mile of the weather data source, which makes the values on the left-hand column extremely accurate. A 10 kilowatt premium panel array with a 38-degree tilt at 180 degrees azimuth will produce energy in a range from 13,673 to 14,899 kilowatt hours per year. The reason these numbers are so important to us is if we continue on to the next slide, we can see that our estimated electricity use annually is 12,931.2 kilowatts annually. As you can see, the minimum amount of power we're going to produce annually far exceeds this value, which is why you can see that our energy rating index, as shown in the center of the page, is a negative value. This means that the home is producing more energy than it is consuming. At the top of the page, you can see the values of energy consumption in mega BTUs, which is a conversion from kilowatt hours. But this kind of shows you more of an analysis over where our energy is actually being used. So you can see that quite a bit of our energy consumption is still coming from our appliances and lighting, but that number is vastly reduced to what it would typically be in a normal home. Now I'm going to kick things over to Mel to talk about the estimated construction budget.
Thanks, Troy. This brings us to the estimated construction budget. This budget includes architecture costs, electrical and mechanical costs, contingency costs, and costs of labor. In addition, this total cost is subtracted from the amount that Veterans Affairs typically gives to veterans with lower limb amputation as a home remodeling grant. With the grant subtracted from the cost, the official total cost is $191,130. The cost per square foot is brought to $64. The average household income in Rolla is $34,934. This is less than the median annual income of $61,937 across the entire United States. This brings us to the 28-36% rule. Most financial advisors agree that people should spend no more than 28% of their gross monthly income on housing expenses and no more than 36% on total debt. Thus, with a median income in Rolla, a homeowner could afford to spend about $815 a month on housing costs. For the estimated monthly cost, the principal and interest is included, property taxes are included, home insurance is included, and utilities are included. This brings the total estimated cost to $225 a month. Thus, using the 28-36% rule, the flight home is financially feasible for a household in Rolla, Missouri. Overall, we have tried to design a sustainable net zero energy home that is family friendly and focuses on key design goals. Considering the shortage of accessible housing in America, ADA compliance has been an important focus for the team. In addition, as poverty rates in young veterans with disabilities rise, millennials may question if purchasing a house is a good investment. The team has created a house that is affordable and has many advantages in its location. Finally, combating climate change and addressing environmental concerns is crucial for the near future. We have designed a net zero energy home with sustainable and locally sourced materials, which will ultimately reduce emissions that will impact the environment. This is Solar House Design Team, and we would like to thank you for your time.